Okay, this unit is going to be on a problem solving technique that we want to teach you as freshmen so that when you use it a lot in chemistry next year, you're not going to see it for the first time and be totally confused. So we'll take this unit slowly and throughout first semester, I'll give you little quizzes to keep you fresh on it after a little review. Okay, so let's start out. We talked about scientific method, we talked about measurements, quantitative measurements require a number. For example, you don't just measure something and give a number. For example, if you say the length of a string is 150, that's meaningless. 150 what? Okay, it could be 150 feet, 150 meters, 150 inches, 150 miles, whatever. So you gotta, after a number measurement, you gotta put a unit. And all those examples, feet, meters, centimeters, etc., are units of length. So a measurement has to have a number and a unit. A number and a unit. You can't just give me a number. No naked numbers. They must have units. There are two systems of measurements. In the United States, we use primarily the English system of measurement. I call it the American system because England doesn't use it anymore. But so the U.S. system of measurement, that's like with inches, feet, yards, miles, gallons, pounds. Scientists in the United States, engineers, and other nations use the metric system. And we'll be teaching you how to work within the metric system. The metric system is also called the SI system, which in French means international system, Système Internationale. I don't know how to say it. So SI system is also called the metric system. So we're not only going to learn how to work within the metric system, but we're going to learn how to convert between the SI system and the American or US system. Okay, so here is, time, seconds, and days. They're units in both systems, the SI, the metric system, and the US system. But when I do a problem, inches to centimeters or vice versa, I'm working between the systems. Converting from American to metric. 50 miles per hour, meters per second. That would again be converting from US units to metric units. Okay, we are going to learn how to do that by a problem-solving strategy that will really help you in chemistry. That problem-solving strategy is called dimensional analysis. It's also called the unit factor or the factor label method. So what is dimensional analysis? You can use it to convert within the United States system measurement or within the metric system or between the metric and the US system of units. Okay, in order to use dimensional analysis, you have to understand what a conversion factor is. One of the videos I had you see describes it as a conversion ratio. Okay, so basically a conversion factor are two terms that describe the same amount but with different units. For example, 1 inch is equal to 2.54 centimeters in the metric system. 1 dozen is equal to 12 somethings. Okay, that could be in the metric or the US system. These are examples of conversion ratios or conversion factors. You will have a whole list of conversion factors. You really don't need to memorize them. You know a few of them already. 12 inches is 1 foot, 3 feet equals 1 yard. So you know some of these, but I'll have them, a bunch of them, on a list that you can refer to when you're doing problems or taking a test on this. Okay, so for dimensional analysis, it's useful to take that conversion and make it a ratio. I can say 12 inches per 1 foot. That's what 12 inches is, 1 foot. And so I can make a conversion ratio or a conversion factor by just putting one of these over the other one. Or I can do it, flip it around, and same conversion factor would be 1 foot per 12 inches. So let's start with a simple example. How many feet, here's a question, how many feet are in 60 inches? Or I could say 60 inches equals how many feet? So first step in dimensional analysis is to write down your known term. And in this problem is pretty easy because that'd be 60 inches. There's only one of them. The next step would be to multiply this known term by a fraction. Well, by actually a conversion factor. Okay, where do you get the conversion factor? You look at a table, but I think we know. We know a conversion factor. We know that. What's the relationship between feet and inches? Well, I know that 1 foot is 12 inches. So I'm going to put that conversion factor in a ratio, a fraction form, so that what my known unit is at the bottom of that fraction. And what I'm looking for, the units you want, on top of the fraction. So I got 12 inches equals 1 foot. Then I put in the numbers so that I'm using that conversion factor right there. 1 foot equals 12 inches. Now, this is really over 1 because it stands by itself. 60 inches is 60 inches over 1. So I have a fraction on that side too. So notice, very important, you got to put the unit that you're given in the denominator of the conversion factor. You can't put it on top. The whole reason for that is it will cancel out. The unit will, not the numbers. And then you can do the math. Which would be 60 times 1 divided by 1 times 12. And that'd be equal to 5. And the unit that remains is feet. Now, you're probably going to do this in your head, but don't resist learning dimensional analysis because the units are not going to be that familiar all the time. Okay, we just basically solved it. Now, I like to take a shortcut, and here's how I do it. My known term, number and unit, and then instead of writing 60 inches over 1 times a fraction, I just make a new section to show that it's a shortcut for showing another fraction. So I bring down the inches, and I'm trying to go to feet, what I'm looking for. I put that on top. Then I think of the conversion factor, or look it up. 12 inches equals 1 foot. And then I cross the unit out, and I left with my answer. So I know I don't need this whole section right here. Another section, because I'm done. Once you get your unit by itself, you are done. So that'd be 60 divided by 12 would be 5 feet. Okay, so I'm going to start doing that shortcut instead of writing 60 times 1 over, instead of doing that mess. So I'm reminding you again, you'll be given the conversion factors on a table. You won't need to memorize them. Okay, here's the table I'll give you. Okay, we have units for length or distance. We have units for area. We have units for volume and for weight and for time. Okay, the red box, the red column on this page and the previous page, you can see those are, except for time, those are U.S. system units. And the ones in the blue box on both pages are system to system, metric system to U.S. system, or vice versa. So, very useful in case you don't know. Most of these conversions you won't know. Okay, now the middle ones, which I'm going to skip for now, except for time, the middle ones would give you the metric to metric conversions, except for time. So let's start doing dimensional analysis with these problems and using that 2 tables that I just showed you. Well, 2 pages of tables. Okay, so 100-acre park is how many square miles in area? Okay, so I'm good focusing on area here. What's my known term? What's my known term? Well, the one with a number and a unit. So that's my known term. I'm going to put it on top. Next thing I do is what? Bring down the unit on top. And what goes here? The unknown. If you find a conversion, if you can find a conversion factor for it. Let's look at our table. Look back to the other page. Is there a table entry with square miles to acres? Okay, if you go 2 pages back, you'll find it right there. So my conversion factor would be what numbers go next to acre and what goes next to square mile. Well, 1 square mile is 640 acres. So the acres cancel out. Do I have square miles now? Yes, I do. So my answer, take out my calculator, 1,000 times 1 divided by 640. Remember, there's just a 1 down there at the beginning, unless it's a ratio that you start out with, which we'll do later. Take out your calculator, and I get 1,000 divided by 640. I get 1.56. Okay, now I really get 1.5625. Repeat, but I'm going to just round it off like money, like a price tag, $1.56, like that. So my answer would be 1.56 square miles, which I can abbreviate like that, right there. Okay, on this one, let's do dimensional analysis. Okay, there's my known term, which I start out with, 26.2 miles. And I'm going to bring miles down, and I'm going to try to find a conversion factor with feet and miles in it. So I found it on the first page of the table at the top. Right here, 1 mile is 5,280 feet. So 5,280 feet is 1 mile. The miles cancel out, leaving the unit that I want, feet, the unknown terms unit. So I know I'm done after I calculate this. So 26.2 times 5,280 divided by 1 is equal to, take out your calculator, and I get 138,336 feet. Okay, so here's the time dimensional analysis problem. So my known term is, well, my unknown is how many seconds. So how many seconds is my unknown? And this is kind of worded kind of confusingly. How long does it take the Earth to orbit the sun once? The Earth goes around the sun once every year. So that's 1 year. So that's my known term, the time it takes for the Earth to orbit the sun. So I'm going to start with that known term. Okay, so 1 year, bring down year, and I'm going to try to go to seconds, but I can't. If you go to that page, the second page of the conversion factors, you will see that there's no year to second conversion factor. So I'm going to have to look at that, another part of that timetable. And this column was right next to that other column. So we're going to have to go from years to months. No, not necessarily. How about years to days? Okay, so change that to days. So 1 year is 365 days approximately. Really, it's 365.25 because of leap year every 4 years. Okay, and then from there, the years cancel out, and I start fresh. I keep on going. Days. Do I know how many seconds are in a day? No, but I know there's 24 hours in 1 day. Okay, is hours what I want? No, I want seconds. So keep crossing out the units that cancel out. Okay, I bring down that top unit like I've done all along. Hours to seconds. I mean, maybe you know there's 3,600 seconds an hour, but I'll just pretend you don't. 1 hour is 60 minutes, and hours cancel out, and that leaves me to bring minutes down, so that cancels out. And everyone knows there's 60 seconds in 1 minute. So my answer is basically 365 times 24 times 60 times 60, which is 3153600 seconds. Okay, seconds is left. I just multiply all the numbers on top, and then I divide by the multiplication of all numbers on the bottom, which is 1 times 1 times 1 times 1, so that's just over 1. Okay, in this one, this is volume. So I went back to that table and printed everything I needed and more. So what's my known term? Well, not cups of water, that's how many. That's my unknown term. So my known term is 30 gallons. I guess fish tank is full of water. Okay, so 30 gallons. And I'm trying to go from gallons to what? Cups. So is there a conversion factor for cups to gallons? Let's look. We got cups here. Let's find all places cups are. Cups to ounces. 2 cups to pints. That's all I got. Okay, so I got cups to pints. Is there anything with pints and gallons? No. Is there anything with ounces and gallons? No. Okay, so what I'm going to have to do is go from gallons to something that's not as small as cup, but the next smaller size. So in a gallon, there's 4 quarts, right? Okay, I'm going to use that. And then I'm going to go from quarts to pints. And then because cups has pints, there is a conversion for cups and pints. That's what I'm going to do. So I'm going to go from gallons to quarts to pints to cup. So the next thing will be quarts. So there's there's where is it? 4 quarts in 1 gallon. Okay, 4 quarts in 1 gallon. Gallons cancel out. I bring down quarts. Then there's 2 pints in 1 quart. Quarts cancel out. I bring down pints. There's 2 pints. Oops. There's 1 pint in 2 cups. 1 pint in 2 cups. So 2 cups is 1 pint. Now there's not always going to be ones on the bottom. Look, 1, 1, 1. It's not always going to be like that. So don't just go randomly multiplying these numbers. So my answer is everything cancels out except cups. So that'd be 30 times 4 times 2 times 2. And I get 480. I get 480 cups. So I'd have to put 480 cups of water into this 30-gallon tank to fill it. Okay, I have to apologize. I started this problem before I pushed the button. So this problem is going to be a little trickier because you'll see why. There's 2 conversion factors, and which makes things different. Not difficult, just different. So let's read through this. You have a $20 bill. Okay, that's a known term, $20. So I wrote it right there. I wrote it right here. Okay, if gas is $3.35 a gallon, okay, $3.35 per gallon. So I wrote that conversion factor as a fraction right there. I could put 1 gallon per $3.35, but I just wrote it like it says here. Okay, here's another conversion factor, 24 miles per gallon. So I wrote it right here, right there. The unknown is how many miles will you be able to drive your car with this $20. Okay, you could start with your known term, miles. I'm sorry, $20. Well, this is weird because, no, it isn't. So I'm going to start with my known term, $20. And I have a conversion factor that what isn't on the table is in the problem. So bring down dollars to gallons. So 1 gallon is $3.35. That's the conversion factor. I just had to flip it around because I had to bring dollars down so it cancels out. Then gallon, bring gallons down, and hopefully I'll be left with the unit that I'm looking for, miles. So it's 24 miles per gallon. So my answer is 20 divided by 3.35 times 24. So I get 143.28. I'll just round it off at the decimal point. So they'll be able to travel 143 miles after paying $20 for that gas. Okay, so on this one, let's see. He picked 83 pecks of pickled peppers. How many barrels is this? Well, I have no clue what a peck and a barrel is. So hopefully, I don't think it's on my table, my conversion factor table. So hopefully it's in the problem. Let's keep on reading on the next page. Okay, so they should have put this all together so we wouldn't freak out. A peck is 8 quarts. A bushel is 4 pecks. Or a bushel is 32 dry quarts. A barrel is 105 dry quarts. Okay, so they wrote for us all the different conversion factors. So there's really 3 of them there. Barrel to quarts, bushel to pecks, bushel to quarts, pecks to quarts. So we got, if we make those conversion factors, you don't have to write both of them. There's 4 of them. So we should be able to solve this now. What is the known term? Well, all the conversion factors are known terms, but if you go to the original question, it reads 83 pecks equals how many barrels? So the known term is 83 pecks. Okay, so we're going to start with 83 pecks. What is my unknown term that I'm looking for? Barrels. So can I immediately go from pecks to barrels? Is there a conversion with pecks and barrels up here? No, pecks and bushels, but not pecks and barrels. So I'm gonna have to find another one with pecks. I guess right here I could use pecks a bushel. So what's the units? 4 pecks per 1 bushel. Okay, so pecks is gone. We're trying to get to what? Barrels. Is there bushels to barrels? Bushels to barrels? No. Only thing with barrels is quarts. So let's try to get bushels to quarts. Okay, so bushels down here to quart. And there's 32 quarts per 1 bushel. So bushels have canceled out. I bring down quarts and I'm trying to get to what? Barrels. Is there one from quarts to barrels? Is there a conversion factor from quarts to barrels? Yes, right here. So 105 quarts is 1 barrel. And I'm done because everything canceled out except barrels. So what I have to do is 83 times 1 times 32 times 1 divided by 4. And then divide again because it's still down there. Divide by 105. And I get 83 times 32 divided by 4 divided by 105. I get 6.32. 6.32 barrels. We're going to now move into converting within the metric system. So you're not going to have to memorize these prefixes, but these are the metric prefixes that we'll be using. The most common ones are kilo and centi. Okay, these prefixes, as I wrote here, can be attached to any unit. For example, basic units could be meters, grams, seconds, anything. Each of these prefixes is represented by a letter. For example, kilo is represented by a lowercase k. Now, the prefix means is substituted in there for a value. So kilo means 1,000. So a kilogram is equal to so many grams. Well, K stands for 1,000. So a kilogram stands for 1,000 grams. Now, scientific notation, we will use when it gets to be a big or really small number. So I could write 10 to the 3 grams for number of zeros that follow the 1. So 1 kilogram equals 10 exponent 3 grams. So 1 nanometer, look it up. You'll get to use this table on the test too, is equal to, I'm not going to write all this. I'm going to write this instead. 10 to the negative 9 meters. Now I could have just said it equals 0.000000678 meters, but that's a pain to write. Okay, so look, the number of zeros is 1 less than the exponent when you're writing it the long way. Okay, so 30 megagrams. That's the capital M, mega. 30 megagrams is 30 times 10 to the mega stands for a million, 10 to the 6. Or you could write 30 with 6 zeros. 15 terabytes, like in a hard drive. 15 terabytes is 15 times 10 to the what? Tera stands for 10 to the 12, a trillion. I'm not going to write that with 12 zeros after it. So basically all we're doing is whatever prefix you have, you just change that to a number. And you multiply by, you multiply that power of 10 by whatever number they give you to start with. Okay, we're going to use dimensional analysis to solve these kind of problems in the metric system conversion. So 420 grams is equal to how many kilograms? So what we're going to do is start with a known term. Okay, bring down the known term unit like I taught you before, and we can go to a prefix of the same unit. So kilo stands for 10 to the 3. So you give the power to the guy that doesn't have a friend, the friend being the K. So 1 kilogram is 10 to the 3 grams. If you don't know a kilo is 10 to 3, you just use that chart that was on the previous page that would be given. So on your calculator, I would do 420 divided by 10 caret 3. There's a little caret sign. Or you can do exponents, but this is easier. And that comes out to 0.420 kilograms because the grams cancel out. Okay, so we're doing the same exact thing that we did with dimensional analysis before. How about this? 0.000719 grams equals how many megagrams? So we start with our known term, 0.000719 grams. And I bring down the unit, and I'm going to go to megagrams. Okay, so remember, this guy has a friend. So 1 goes next to that. He already is hooked up with someone. And so the mega stands for a million, or 10 to the 6. So this would be, take your calculator out and do 0.000. You don't have to write this. Divided by 10 caret 6. It comes out to be this number, 7.16 times 10 to the negative 10 megagrams. Okay, it's a very small number. Okay, right here, you're not going to the basic unit. You're going from a prefix unit to another prefix unit. So I would look up, it's a little more involved, not that much. So you look up what mega means, that's 10 to the 6, and what centi means, that's 10 to the negative 2. Okay, so you write your known term, 22.6 megaliters. Okay, you bring down megaliters, and you always go to the basic unit, which would be whatever the second letter is. Okay, you put 1 next to the guy who already has a friend, mega, and mega stands for 10 to the 6, so I'll put 10 to the 6 right there. Crosses out the milliliters, megaliters, sorry. And then I bring down the L, and now I can go to what I'm looking for, centiliters. Centi stands for 10 to the negative 2. So I put that right there next to the guy who is lonely without a prefix. And I use my calculator to 22.6 times 10 caret 6 divided by 10 caret negative 2. Make sure you push the negative in parentheses sign on your calculator, which is on the bottom row. Gets this big giant number 226 1, 2, 3, 4, 5, 6, 7 with 7 zeros. Okay, maybe your calculator put it into scientific notation, or you could do that by pushing the mode button, but I won't teach you that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this times 10 to the 9 centiliters, because the liters cancel out. Now, this answer is perfectly fine as well. Okay, in this next problem, we're going prefix to prefix. So basically, you start with your known term, then we'll go to the basic unit, and then we'll go to the other prefix unit. So this funny sign is micro, 10 to the negative 6. You can look this up on your table that I just showed you before. Nano stands for 10 to the negative 9. Okay, so we're going to start with our known term, 2260 micrometers. We're going to take the prefix unit down and go to the basic unit, which is always the second letter. And the guy who gets the number that micro stands for is the lonely one, the one without a prefix. So, looking at it right here, 1 micrometer is 10 to the negative 6 meters. I'm going to bring meters down now after crossing these units out because they cancel. And I'm going to nanometers. Nano stands for 10 to the negative 9. And you put that next to the basic unit, the one who doesn't have a prefix. Okay, so my answer would be 2260 times 10 caret negative 6 divided by 10 caret negative 9, which equals 226 with 4 zeros. Nanometers. Let's do another one. We're going from 0.75 milliseconds to how many deciseconds? Okay, so again, I'd have to look up what milli stands for if you don't know it on the table, and what deci stands for if you don't know it on the table. Okay, so I'm going to start with my known term, 0.75 milliseconds. Bring down that known term, that known unit. Again, I go to the basic unit as my second step. Then I go to the other prefix unit that I'm looking for. So, milliseconds, not to deciseconds right away. Okay, it has to go to basic unit first. So milli stands for 1 millisecond stands for 10 to the negative 3 seconds. Again, if you have a prefix, don't put anything but a 1 next to it. The one who gets the number that the prefix stands for is the one that is by himself, seconds. Okay, so these guys cancel out. Then I'm going to bring down seconds, and I'm going to go to deciseconds. Deci stands for 10 to the negative 1. So I worked this out on my calculator. 0.75 times 10 caret, 10 caret negative 3 divided by 10 caret negative 1. That comes out to 7.5. My calculator says 7.5 times 10 to negative 3, but that you might have gotten on your calculator. 0.0075. Either one's the right answer. Deciseconds. So here's some problems like the ones we just did to try. Some are easier. Okay, so my known term obviously is that. So I'm going to write 1.23 10 caret 5. Be sure you write the units. Okay, remember you bring megameters, the known unit, down, and you would go to the basic unit, next step, and that's where I can stop. Okay, so I look up mega. Mega means 10 to the 6. So 10 to the 6 goes with the guy, the basic unit, the one without a friend, without a prefix. And I'm done because the megameters cancels out, leaving meters. So my answer would be 1.23 times 10 to the, you could use the power rule, just add the exponents when it's multiplying 2 powers of 10. Or you can just work it out. 1.23 times 10 caret 5 times 10 caret 6. And you'll get exactly the same answer. Okay, here's another easy one. We're going to go from meters to nanometers because that's my known term. So write down your known term. 6.5 times 10 caret negative 6. And then don't forget to write the unit. So bring down the known terms unit and put the unknown terms unit on the other side. Look up what nano means. Nano means 10 to the negative 9 power. And put it next to the guy without a prefix. The basic unit without a prefix. So again, you could solve this if you know your power rules, exponent power rules. Okay, so this would be 6.5 times 10 to the negative 6 minus a negative 9, because when you divide powers of 10, you subtract the denominator's power from the numerator's power. So that would be basically 6.5 times 10. Negative 6 plus 9 is negative 3. If you did it on your calculator, you would go 6.5 times 10 caret negative 6 divided by 10 caret negative 9. And you'll get the same answer, or you might get .0065, which is the same answer. Okay, it looks like I'm just giving you easy ones here. So start with your known term, 6.5 times 10 to the 7 nanometers. Bring down the known unit. Put the basic unit on the other side, and we're done. It's a two-step problem after we put the numbers in, of course. So nano means 10 to the negative 9. That goes next to the guy that doesn't have the prefix. So that'd be 10 times 10 to the negative 9 power next to the meters. And this is just 1. So my answer would be 6.5 times, use the rule, 7 plus a negative 9. When you're multiplying, you add the powers, exponents. 7 plus a negative 9 is negative 2. Okay, and the answer would be meters. You probably will get 0.065 when you do it on your calculator, which is the same exact thing. Either answer is correct. Okay, so we're finally on one where we have two prefixes. So you start with, first of all, maybe look up on a table. Micro stands for 10 to the negative 6. Kilo stands for 10 to the third power. Okay, so my strategy would be to start with a known term. Okay, so I'm going to go for micrometers, and I can't go directly to kilometers. I have to go to meters first, then go to kilometers. That's my strategy. Okay, so 5.8, write your known term down. Micrometers. I know I'm going to need 3 sections because I got 3 places here. So micrometer goes, bring down micrometers, go to meter. Micro stands for 10 to the negative 6, so put that next to the guy that doesn't have a prefix. 1 next to the micrometers. The micrometers cancel out, bring down the meters, and we're going to kilometers. Kilometers stands for 1,000, so put the 1,000 or 10 to the 3 next to the guy that doesn't have a prefix. So this would be 5.88 times 10 to the 8 times 10 to the negative 6 divided by 10 to the 3. Okay, so what I do, I mean, you can do this on your calculator, but this is a shortcut. 8 plus negative 6. So that equals 5.88 times 10. 8 plus negative 6 is positive 2. On top, divided by 10 to the 3 on the bottom. Now you can use your calculator, or you can use the exponent rules. When you're dividing exponents, just subtract. Okay, so my answer would be 5.88 times 10 to the 2 minus 3 is negative 1. And that would be, if you do it on your calculator, you probably would get this answer, 0.588. And the unit that remains is kilometers. First page. Okay, so let's see, where is it? Right here. Top, blue box. We got inches to centimeters. Okay, so that will get us. So now we're gonna use the blue boxes on this table as we switch between the metric and US conversions, and maybe even have to convert metric to metric. So let's see what I mean. Okay, so let's go. Okay, so we're looking for 100 millimeters is how many inches. So if you look at your table, there's nothing with inches to millimeters, but not a big deal. When I looked at the table, I saw that 1 inch is equal to 2.54 centimeters. So I'll start with my known term, 100 millimeters. And I had to get to centimeters. So here's my strategy: millimeters to meters to centimeters, and then to inches using this conversion. So 100 millimeters, bring down the millimeters, go to the basic unit. Milli stands for 10 to the negative 3. Put it next to the basic unit. Cancel out the units. I'm going to go to centimeters now. Bring down the meters to centimeters. Little c stands for 10 to the negative 2. You can look that up on the table. Okay, the meters cancel out, leaving centimeters, and I can go to use this conversion factor over here. So bring down centimeters to inches, and so 2.54 centimeters is 1 inch. So I would do 100 times 10 to the negative 3 times 1 times 1 divided by 10 to the negative 2 divided by 2.54. Now, you can all do this on your calculator. Or I can do the exponent rule, but let's just do the calculator. 100 times 10 caret negative 3 divided by 10 caret negative 2. Divide again. Okay, don't multiply because it's in the denominator, so you have to divide. 2.54. How about this one? Years to minutes. Okay, we did one like this already. Look on your table for time. So we're going to start with 32 years. I'll just put Y for years. Okay, let's do this next one here. Years to minute. Okay, this is like, look at your table if you need to. So start with your known term, 32 years. Okay, we can't go from years to minute. I don't know that conversion. But if you look on a table, you know that there's 365 days in 1 year. Okay? The years cancel out. Bring down days. I don't know how many minutes are in a day. But I know that there's 24 hours in a day. Days cancel out. Not the unit, just the units, not the number. Bring down hours. And now we can do 1 hour is 60 minutes. Okay, so I just multiply all those numbers because there's only ones on the bottom. So I get this big number, 1681920 minutes. Okay, I could probably break that if you did this in your calculator, it might put it into scientific notation. So I would write 1.68 times 10 to the 1, 2, 3, 4, 5, 6, 7 minutes. Okay, but this answer is just fine as well. You could even round that off if you want to 2 significant digits. I won't do that. Let's do the next one. Okay, we're going from millimeters to feet. So here we are in the metric. Now we're going to the English system. So let's think of our strategy. So we're going to start with millimeters. And there's various ways you can do this. I could change that to meters and then centimeters, then inches of feet. But if you look at the table, I bet there's a conversion for meters to feet. Let me look. And yes, you can see 1 meter is 3.281 feet. So I can go from meter to feet. Again, I could go millimeters to meters to centimeters to inches to feet. That's time consuming. I take a shortcut. So let's do this strategy here. So I'm going to start with 12,000 millimeters. That's my known term. I'm going to go to meters. Milli stands for 10 to the 3. Cancels out the millimeters. Bring down meters. And I can go directly to feet using this thing here. So 1 meter is 3.281 feet. So 12,000 times 10 caret negative 3 times 3.281. And I get 39.37. 39.372. So I'll leave it like that. 39.37 feet. Because all the other units cancel out. This one, we already did something like this. So here's your known term. Can I go seconds to years directly? No. I'm going to have to go seconds to minutes to hours to days to years. Okay, so 6 times 10 is 6 seconds. Bring down seconds. Bring it to minutes. So there's 60 seconds in 1 minute. Okay? Seconds cancel out. Bring down minutes. And there's in 1 hour, there's 60 minutes. Minutes cancel out. Bring down hours. Go to days. There's 24 hours in 1 day. Then finally, hours cancel out, bring down days. Then here's years. So there's 365 days in a year, 1 year. Days cancel out. We're finally done after we calculate this. So you would do 6 times 10 caret 6 divided by 60 divide again by 60, divide again by 24, divide again by 365. Whenever it's in the denominator, you want to divide, even though you would think multiply. So I get for my answer 0.1902, so it's 0.19 years. Okay, this next one is pretty cool because it starts with a ratio. Okay, so I had to change kilometers to meters and hours to seconds. I had two things to change. So start with your known term, 27 kilometers per hour. And let's change kilometers first. Kilometers to meters. So K, little k stands for 10 to the 3. Goes next to the basic unit. Okay, kilometers cancel out, units do. Okay, I'm going to keep the meters because that's what I want on top. Then seconds, we got jump over to the next section and put hours. We're changing hours to seconds. We're going to have to put hours on the other side, which happens to be the top. So 1 hour is how many seconds? Well, I know it's 3,600, but 1 hour is 60 minutes. Francis crosses out the hours, and let's change minutes to seconds. Bring up the minutes. Okay, in 1 minute there's 60 seconds. So the minutes will cancel out as well. Okay, so I'm left with 27 times 1,000, which is 10 to the 3. Times 1 times 1 divided by 60, divided by 60 again. So I get I get 7.5. Meters over seconds, so I converted. So it's kind of tricky. You have to convert both units in the known term. Okay, number 7, let's see. I'm going from micrometers and to inches. I can't find that on the table. But I could go micrometers to meters. To centimeters to inches. If you look at that table, like we did that before. Okay, look at the table for length. Okay, I have 2.54 centimeters is 1 inch, like I showed you before. Okay, so let's do the math. So I'm going to start with 500 micrometers. I'm going to basic unit. Bring down micrometers. Go to basic unit. Mu is 10 to the negative 6. Microsine is 10 to the negative 6. Okay. I'm going to cross out micrometers. I'm going to bring down meters now. And we're going to change that meters to centimeters. Find my strategy up here. Okay, centi stands for 10 to the negative 2. Okay, 1 centimeter is 10 to the negative 2 meters. Okay, now I can bring centimeters down. I know there's on the table I used 2.54 centimeters is 1 inch. So I'm finally there. So the meters canceled out, the centimeters cancel out, leaving inches. So I'd write 500 times 10 caret -6 divided by 10 caret -2 divide again by 2.54. And I get 0.019685. 9685. Okay, of course I'm not going to write all those numbers. Inches. Okay, number 8, we're going to have to change miles to feet, and we're going to have to change hours to seconds. So let's see, 60 miles per hour. Write down your known term. Okay, it's going to be easy to change hours a second. Let's do that first. So 1 hour. There's nothing there over in the known term. That's a 1. So I'm going to bring hour up. 1 hour, there's 60 minutes. Okay, the hours cancel out. Look, I'm bringing up to cancel instead of bringing down because I decided to do the hours first. Hours to seconds, and then bring up minutes, and we're going to go to seconds. 1 minute is 60 seconds. So minutes cancel out. So I have seconds, so I'm finished with the bottom part. Let's fix the top part. Now, if you look at the table that I keep on printing out, what I'm going to do is bring miles down across everything. And so 1 mile is 50 to 80 feet. You can look that up on the conversion chart. And now these cross out, and I'm left with feet per second. So let's do that calculation. So it'd be 60 times 50 to 80 divided by 60 divided by 60 divided by 1. And I'm getting 88 feet per second. So 65 miles per hour is 88 feet per second. This next one is mileage, like gas, miles per gallon. So I assume there's a 1 there. So I'm going to have to change the miles to kilometers. I think there's a conversion direct on that. I got to change gallons to liters. I think there's a conversion for that too. So why don't you look back at the table? So 1.609 kilometers equals 1 mile. I found from the table. Then I found that 1 gallon is 3.785 liters. From the table, the volume table on the first page. Okay, so let me just set up 17 miles per gallon. Let's change the miles first. 1 miles to what? To kilometers. I can do that using this conversion right here that I found. So 1.609 kilometers is 1 mile. Okay, so the miles cancel out, leaving me kilometers, which I want, so I'm going to leave that alone. So the next thing I do is bring gallons to the other side and change it to liters. And from the conversion factor that I found on the table, 1 gallon is 3.785 liters. So the gallons will cancel out, give me kilometers per liter, which I want. So my answer would be 17 times 1.609 divided by 3.785. And I get 7.22668428. So let's round that up. Okay, 7.22668, blah, 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 etc. Let's round it up like a price. $7.23. Okay, 6 brings the 2 up. So, kilometers per liter. Okay, and then here's a weight one. 1 U.S. ton is how many kilograms. So you're going to have to look again at that conversion table, but for weights. Okay, so where's U.S. tons? Okay, this is U.S. So 1 ton is 2,000 pounds. Okay, so I can take tons to pounds. And then to go to kilograms, I got kilograms and pounds. So I can go pounds to kilograms. So that'd be a 3-step problem. So 1 ton, U.S. ton. There is a metric ton that's different. Use the U.S. ton. Okay, 1 U.S. ton. Bring down tons. Change it to pounds. There's 2,000 pounds in 1 ton. And then bring down pounds. And change it to kilograms. There's 1 kilogram is 2.205 pounds. So my answer is just simply 2,000 divided by 2.205. Which is, hold on, 2,000 divided by 2.205. I get 907.0. So that's how many kilograms are in 1 U.S. ton.